Good morning. Is my voice clear? Okay, write down the class starting date and time. Hmm. Okay. Hmm. In the last class, we have discussed exercise 1.3. I think all the question I have discussed except question number 6. Okay. Otherwise, I explain all these things. Okay. And did you complete this exercise? Did you complete this exercise? I don't understand your language. Tell me in English. Yeah. Okay. Remaining except 6, 7, 8, you can do. You did all this question, na? Okay. Look the question number 6. Look at several examples of a rational number. Look, in the last class, if you remember, we have discussed decimal expansion of a real number. Decimal expansion of a real number. In this, we have studied decimal expansion of a rational number. Decimal expansion of a rational number. If remainder equal to 0, if remainder equal to 0, if remainder equal to 0, it is which type of a decimal? If one the division of a p upon q, if the remainder is 0, it is which type of a decimal expansion? No, no, my question is, look, if I divide a rational number, if I divide a rational number, if I divide p upon q of a rational number, two conditions are there. Either remainder equal to 0, either remainder does not equal to 0. I am telling about rational number. If I divide numerator of a rational number by the denominator, two cases are there. Either I am getting remainder equal to 0 or remainder is does not equal to 0. If remainder equal to 0, it is which type of decimal expansion? Terminating. If remainder equal to 0, it is terminating decimal expansion. If remainder is does not equal to 0, non-terminating are of two types. So it is non-terminating, recurring, because I am telling about rational number. Non-terminating, non-recurring are the example of a irrational number. Are the example of a irrational number, and I cannot write irrational number as p upon q. Okay, if I don't write p upon q, then how I divide? Okay, this is for only rational number. Look the question. Look at the several example of a rational number. It is telling about rational number. If I divide denominator numerator of a rational number by the denominator, two condition will be arise. In one, r is equal to 0 when remainder equal to 0. In another case, r does not equal to 0. If r equal to 0, it is terminating decimal expansion. If r does not equal to 0, it is non-terminating recurring. Non-terminating recurring. And there will be no chance we will get non-terminating non-recurring, because non-terminating non-recurring are not comes under irrational number, it comes under irrational number. Okay. So this question is saying, look at the several examples of a rational number in form p upon q, where p and q are integers with no common factor other than 1 and having terminating decimal representations expansion. Can you guess what property q must satisfy? Okay, that means the question is saying, look, if you remember, I was telling one sentence in the last class that every rational number numerator and denominator are co-prime. Did you remember this sentence?
Yes, sir.
Every rational number, numerator and denominator are co-prime. Every simplest rational number. Simplest, okay.
Okay, sir.
What does it mean? Look, co-prime means HCF should be 1. HCF equal to 1.
1.
Suppose 3 upon 11. Here 3 and 11 are co-prime because 3 factor is 1 and 3, 3 factor is 1 and 3, 11 factor is 1 and 11.
Yes,
Okay,
sir. Yes.
so here HCF is 1, so they are co-prime. Look my sentence. Every simplest rational number, numerator and denominator are co-prime. You can take 2 upon 6. It is also a rational number.
No, sir. Rational number, yeah.
Rational number,
But
but
not co-prime.
2 and 6 are not co-prime, but it is not in simplest form. It is not in a simplest form. I can simplify it become 1 upon 2. Now if you check 1 and 2 become
1 by
co-prime.
3, sir.
1 by 3 it become co-prime. Okay, you remember this concept?
Yes, sir.
And now try the question. Look at the several example of a rational number in the form p upon q, where p and q are integers with no common factor other than 1, having terminating decimal representation. Can you guess what property q must satisfy? The question meaning is, tell me, three example of a rational number, and it should be in simplest form. It should be in simplest form.
5 by 11,
5 by 11,
2
2
by
by
3,
3,
6 by 11.
6 by, instead of 11 I am taking 5. Okay, look there, decimal expansion. If I divide 5 by 11, if I divide 5 by 11, before dividing I am telling 100% in these two cases I will get non-terminating recurring decimal. How I am telling? After doing this you will understand. Look, if I divide p upon q of a rational number, two conditions will be arise. Either remainder equal to 0, nor remainder does not equal to 0. Without doing division, I am telling in these two cases 100% I will get non-terminating recurring decimal. Non-terminating recurring decimal. There will be no chance the result will be a terminating decimal. How I am telling? Look, first to try the decimal expansion. 11 0 0, 5 decimal 0, 50, 11 4 44, 6 60, 11 5 55,
5.
again 5. Look, same pattern is repeating. What I am telling? 100% in this case I will get non-terminating recurring decimal. Non-terminating recurring decimal. That means 5 upon 11 decimal expansion is 0.4545. Okay?
Okay, sir.
0.45 bar. Look the second example. Here also I will get non-terminating recurring decimal. How? Look. 0, 20 decimal, 3 6 18, 20. Look, the pattern is repeating. Here I am getting 0.6 bar. In the third case, without division, I am telling I will get a terminating decimal. That means remainder equal to 0. How? Look, 6, 5, 5 1 5, 1, decimal, 0, 10, 5 2 10. 5 2 10. Are you looking?
Yes, sir.
Okay. So, what are you looking? When the when the rational number decimal expansion become terminating, are you looking any pattern?
Sir?
Are you in these three rational number? Are you looking any pattern?
Yes, sir.
No, what is the pattern? Guess it.
Sir, Prime.
Prime.
File.
No. My question is, are you looking any pattern in which you are getting terminating and in which you are getting non-terminating?
No, sir.
No. Take another example. Okay, the example is 3 upon 10. 3 upon 10. First example. Then 11 upon 2. Then 13 upon 5. Then 6 upon 15. No, 6 upon 15 is not. 6 upon 7. 3 upon 10. 100%, I'm telling 100% you will get terminating decimal. 11 upon 2, 100% you will get terminating decimal. 13 upon 5, 100% you will get terminating decimal. Means this decimal expansion is terminating. Okay?
Okay, sir.
Here you will get non-terminating, non-recurring. Okay, that means one sentence you remember. If PQ co-prime, because it is already telling you have to take PQ as co-prime. Look the denominator Q. Q. If Q having
Factors.
factor 2, 5 and both 2, 5 and 2 or 5 or 2 or 5 or both. In that case only you will get terminating decimal. You understand my sentence?
Yes, sir.
Three. Only the condition if the Q factor of a Q having 2 or a 5 or both. Okay? Only 2
Okay, sir.
or only 5 or only, sorry, both 2 and 5. Expect Except this, if the factor of a Q having 2 with any other prime number, it is not valid. 5 with other prime number, it is not valid. Okay? 2 and 5 with other prime number, it is also not valid. You understand or not?
Yes, sir.
You remember only one condition. You will get terminating decimal if the factor of a Q having 2 or 5 or both. Look here. Look here. In 3 upon 10, denominator is Q na? Sorry, Q is equal to 10 na?
Mm.
Then tell me what are the factor of 10?
2 and 5.
1, 10, 2 and 5. Leave the.
Go.
Look here. 2 and 5 both contain.
Mm.
So 100% here we will get a terminating decimal. Check once. 3 upon 10. 0, 3,
0.
30. It is a terminating decimal na?
Mm. Yes, sir.
Okay. Otherwise you remember one thing. I can write Q as 2 power m into 5 power n. Means 2 और 5 के प्रोडक्ट में कन्वर्ट कर सकता हूँ. If it is possible, then we will get terminating decimal. Here you like 10. I can write 10 as 2 into 5 na?
Yes, sir.
Then look 11 upon 2 also.
Mm.
The Q content factor as 2. So here also you will get what? Terminating decimal. Terminating
Decimal.
11 upon 2. 2 5s are 10. 1 decimal 0. 2 5s are 10. Look here also I am getting terminating na? Because in the factor of a Q having 2. Only 2, only 5 or 2 and 5 both. Okay?
Okay, sir.
Then third case look 13 upon 5. Its decimal expansion will be which type? Tell me. Terminate.
terminating.
5 2 ja 10. 3 decimal 30. 2 6 ja 30. Sorry, 5 6 ja 30. In last case,
No, sir. It's not terminating, sir. Not terminating.
non-terminating, repeating. Look, 6 divided by 7. 7 1 ja, sorry, 7 0 ja 0. 6 60. 7 8 ja 50. 6 4 40. 7 5 ja 30. 5 5 0. 7 7 ja 49. 1 0 7 1 ja 7, like this. It will be non-terminating but repeating. Okay. If you do the decimal expansion, you will get non-terminating. Then when will you get terminating decimal? The conclusion is, if the factor of a q, if the
Factor of a cube.
factor of a q contain 2 5 or both, 2 5 or both.
Both.
Look, 11 upon 15. This is terminating na? Sorry, this is a co-prime na? 11 and 15 are co-prime na?
Yes, sir.
What are you thinking? Its decimal expansion will be?
Decimal expansion. Terminating, sir.
Okay. What are the factor of 15? But I can convert it 15 as uh,
Right. Oh, no, sir, non-terminating.
5 and 3. Here 5 is there, then why 3 is there? Only 2, only 5 or both? Irrespective of this, if you have anything, that means you will get non-terminating, non-recurring decimal. Okay? If you look, then check.
Uh,
11 by 15.
11 by 25. 20. Yes, sir.
11 0 15 15 7 ja 105.
7, sir.
Then 5 0 15 3 ja 45. Look, the pattern is repeating now.
Yes, sir.
Why you will get here non-terminating? Because its factor have the 15 factor is 3 5. 5 is there, but due to this 3, only 5, only 2, or both 2 and 5. But here 3 is there, na? That's why we will get. That means I can write q as 2 power n, or q as 5 power n, or q as both 2 power n into 5 power n. Expect
Sir, then 11 by 25 is terminating, right, sir?
11 upon 25. Yeah, terminating. Because I can write 20. Look the two condition. Q equal to 2 raised to the power n, or q is equal to 5 raised to the power n, or q equal to 2 raised to the power n into 5 raised to the power n. These three conditions.
Okay, sir.
Sir, here you look 25. Can I write 25 as 2 raised to the power n? Not possible.
Yes.
5 raised to the power n?
5 is 2.
That means 100%. Look, 11 upon 25. 25 0 ja 0. 11 decimal 0. 25 4 ja 100. 10 0 100.
0. Got it, sir.
Okay. Either you can write q, your means your denominator, as 2 raised to the power n, or 5 raised to the power n, or both 2 raised to the power n or 5 raised to the power n. Irrespective of this, like 15. 15 upon 11. Can you write 15 as 2 raised to the power n? No. Can you write 15 as 5 raised to the power n? No. Can you write 15 as 2 raised to the power n or 5 raised to the power n? Both? No. So that's why here you will get non-terminating recurring decimal. Okay. Now you understand clearly.
Yes, sir.
This you remember. Okay. Look here. 5 upon 6. 5 upon 6. 6 having 2 raised to the power n into 3 raised to the power n.
Yes,
So are you thinking here you will get
non-terminating.
yeah, non-terminating, because look, 0, 5, 50, 6 4 ja 48, 2 0, 6 3 ja 18. It's repeating. It's repeating. So you remember, if you can write q as a 2 raised to the power n, or q raised to the power, sorry, 2 or 3, 5 raised to the power n, or both. If you can able, then you will get terminating, otherwise you will get non-terminating. Okay?
Yes, sir.
Then come to question number 7. Write 3 numbers whose decimal expansion are non-terminating and non-recurring. Alright, you have to give 3 example. Any example you can take. What is the value of pi? 1 point, 3.141, 3.141,
3.145. Yes, sir.
5 dot. You can take any 2. What is the value of root 2? 1.414.
12135.
You can take any 3 example, but whose decimal expansion should be non-terminating and non-recurring. Okay, you understand?
Yes, sir. I wrote it already.
Okay. Find the different irrational number between the rational number 5 upon 7.
Where I got, sir? 0.7289.
Okay, fast you convert it into, find it is a decimal expansion. It is
0.
the,
Sir.
okay. Okay, by looking this, tell me, in 5 upon 7, what will be the decimal expansion? Terminating or non-terminating recurring?
Terminating recurring.
Non-terminating recurring. Because you can never write the q as 2 raised to the power n, या फिर 5 raised to the power n, or both 2 raised to the power n or 5 raised to the power n. That's why. Okay, find its decimal expansion. Find its decimal expansion in between these two number, but it should be non-terminating. Okay.
No.
Then you know how to classify.
Yes, sir.
It's such an easy question. No need to explain. Okay. Now we will check operation on real number. Operation on a real number.
Real number.
What do you mean by operation on real number?
Operation of
Operation on real number. Okay. Before this, okay, tell me something. Hmm. Just wait. I'm checking what is inside it. Hmm. Okay. Look some property. Look some property. Okay. Which is important. Try to understand. Okay. Tell me. If I add one rational number with a irrational number, answer will be how much?
R plus
Rational number. It is not real number. It is irrational. Okay. Here R means
rational.
rational. IR means irrational. IR means
Irrational.
before doing operation on real number, look on the property. My question is real number plus rational number plus irrational number. Answer will be what? Rational number minus irrational number. Rational number multiplied by irrational number. Rational number divided by irrational number. Answer will be how much? Means your option is rational or irrational.
Rational, sir.
Okay. If you add one rational number with irrational number, your answer will be rational or irrational. My question is that.
Irrational.
Remember, if you add a rational number with irrational number, or subtract or multiply or divide, always you will get irrational number. Always you will get a
Irrational number.
irrational number. This is the property. This is the property.
Okay, sir.
I am taking one example for addition. 2 plus root 3. 2 plus root 3.
3.
2 is a rational number. 2 is a
Rational number.
root 3 is a irrational number.
Yes, sir.
And I am telling 100% you will get irrational. 100% you will get a irrational. Look. 2 plus. What is the decimal expansion of root 3? 1.3. 1.372 1.372 dot. Okay, the 2 plus 1 3 3.372 dot. Look, it is a rational or irrational?
Irrational, sir.
Irrational. Now you understand?
Yes, sir.
If you add, subtract, multiply, divide a irrational number with a real number, 100% you will get irrational number. Okay, for for addition I am giving the example. For subtraction, look, only change the sign, only change the sign. 2 minus 1.372, it will be 1.372 dot dot. It is a irrational number na? Okay,
Okay, sir.
then for multiply, look, for multiply, rational number with irrational number, and remember, during multiplication the rational number should not be 0, the rational number should not be 0
0.
except 0, because if you multiply 0 with any number your result become 0, or if you taking 0 multiply with root 2, your answer will be how much? 0. So you are telling, sir, you are telling rational into irrational is irrational always, but here I am getting rational, it is not applicable for 0. Okay, except 0, look, 0 नहीं होना चाहिए. Suppose I am telling the rational number as 2, okay, and irrational number root 3, irrational number
Root 3.
root 3. Okay, what is the decimal expansion of root 3? 1.372 dot dot.
Yes, sir.
Look, how you multiply if you don't know the decimal expansion? That means it is continuing, na?
Yes, sir.
That means when you multiply, your answer will be also continuing. Are you understand or not?
Yes, sir.
So you will get irrational number. Okay. Then division. Division also same case. The rational number should not be 0. The rational number should not be 0.
0.
Or otherwise 0 upon root 2. Your answer will be how much? 0 upon root 2. How much your answer?
Root 2
0 upon root 2. 0?
0.
And 0 divided by any number 0. But here I am telling not, this rule is not applicable for 0. Okay.
0 is an exception.
0 is an exception. Or you can take any number. 2 divided by root 2. Here also 2 divided by root 2 value is 1.414. If this is non-terminating, non-repeating, your answer will be also that. You understand this concept?
Yes, sir.
Okay. Then move to property number 2. Property number 2. The property number 2 is telling irrational plus irrational. Irrational plus
Irrational.
okay, tell me. Rational plus rational, your answer will be what? Rational. Rational minus rational, your answer will be rational. Rational multiplied by rational, your answer will be rational. Rational divided by your answer will be rational. But here I am telling irrational plus irrational, then irrational minus irrational, then irrational into irrational, irrational divided by irrational. What are you thinking? Your answer will be what?
Irrational, sir.
Okay, your options are rational, irrational, irrational, and rational. Which one is correct? 3 options are there.
Rational.
You have 3 options. It will be irrational or rational. It will be irrational or
Rational.
rational. It will be irrational or rational. It will be irrational or rational. Look, suppose I am taking one example. Root 3 minus root 2. Root 3 minus root 2. What is the sorry plus? What is the decimal expansion for root 3? 1.372.
1.41.
414. If you add, your result is 426, 718, 7112. Dot, dot, dot. Here irrational plus irrational, you are getting irrational na?
Yes, sir.
I am telling sometime you will get your result as irrational, sometime you will get result as rational. Okay, in the first example I am getting irrational, but look the second example. Okay, tell me first, tell me. Just wait. 3 plus root 2, it is rational or irrational? 3 plus root 2 irrational, plus 4 minus root 2, it is rational or irrational? Because few seconds ago we learned na irrational plus rational, irrational. So this is irrational, this is irrational. Look, if I simplify, plus root 2 minus root 2 cancel. 3 plus 4, answer will be how much? 7. 7 is a rational or irrational? I am taking two irrational number and I am getting result as a rational. So you understand?
Yes, sir.
Same thing for a subtraction also. You can take your own example. For division I am writing, look. Root 3 into root 2, your answer will be how much?
Root,
Root 6. No need to apply. Root 6. Same thing. Root 2 into root 2, your answer will be how much?
root 4.
Root 2 into root 2. Okay, root 4. Or you can evolve
Answer
2. So in one case you are getting rational, in one case you are getting irrational.
Okay, sir.
Same thing for division. Root 5 divided by root 5. Your answer will be how much?
1.
1. That means irrational divided by irrational, your answer will 1. Do you understand the property 1 and 2?
Yes, sir. Division 1.
Oh,
Division.
look na.
Square root of 1 by square root of 3.
In this case you are getting irrational number na.
Yes, sir. Exception. Okay.
Means here irrational plus irrational, irrational. Look, if you are taking both irrational, the result may be rational, may be
Irrational.
irrational. This is the two property. You understand?
Yes, sir.
Then look the, based on this property, look the, check whether 7 root 5. 7 root 5.
7 root 5.
Look, 7 is a rational number.
Yes, sir.
You multiply with irrational, your answer will be how much? Irrational. Your book is doing, look, he is putting root 5 value. Okay. That means 7 into root 5 value is 2.236 dot 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 dot. And if you know the property, you can directly write.
Yes, sir.
Directly write, we know that rational into irrational. Rational
Into irrational.
result always be irrational. The result always be
Irrational.
irrational. So 7 is irrational, root 5 is irrational, so their product will be irrational. You can write like this, otherwise if you know the root 5 value, you can multiply or show the result. Okay?
Okay, sir.
Same thing, 7 upon root 5. Look, 7 is a rational number,
Yes, sir.
root 5 is
Irrational.
so your answer will be
Irrational.
irrational. Look, your book is doing like this, 7 root 5. Remember, you never have a irrational number in your denominator. Okay?
Okay.
That means if your denominator having a irrational number, you have to convert that irrational number into rational. How? By multiplying same number. By multiplying same number. After few time we will study rationalization. In that we will cover this chapter. Okay, this concept. So why I am multiplying root 5 here? Because I know root 5 into root 5 becomes 5. 7 root 5. Okay. So here you look, 7 into, according to your book, if you know the property, you can directly write the answer. Okay, but in your book it is like doing like this. 7 into root 5 value is 2.236 divided by 5. Okay. If you multiply, you will get one number. If you divide, that number means if you multiply, you will get one non-terminating, non-recurring. If you divide by 5, your answer will be non-terminating, non-recurring. That means irrational number. Okay.
Okay, sir.
Root 2 plus 21. Your answer will be how much?
Root 2 plus 21.
Mean irrational or irrational?
Irrational.
Irrational. Because here root 2 is a irrational number, 21 is a rational number, and I know rational plus irrational, my answer will be irrational. Something. Pi minus 2,
Irrational.
irrational. Look here. All these non-terminating, non-recurring decimals, so all these are irrational number. Now let us what generally happens if we add, subtract, multiply, divide, take square root and even nth root of this irrational number. For n is any natural number. Let us look at some example. Okay, look some example. 2 root 2 plus 5 root 3. How to add? Look, addition. Addition of a rational number, because we are we are learning operation on real number, na?
Yes, sir.
Addition of a real number. Addition of a
Real number.
irrational number. Look, we are learning operational real number. Under real number category, two number are coming, rational and irrational. From the beginning of your study career, you know how to add, subtract, multiply, divide rational number.
Yes, sir.
Now focus on irrational number. Addition of irrational number. Look, the question is saying 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. You have to add. You have to add. Do you know how to add like term in algebra? 2x plus x. Your answer will be how much?
4x.
2x plus x.
2x plus x. 3x.
Hmm. It is called like term. Like term means 2 having x term.
Same.
I think it's called term. Term. Same. 3y plus y. Your answer will be how much?
2y plus
3y plus y.
4y.
2y plus 3z. Your answer will be how much?
2y plus 3z itself, sir.
Yes, sir. Because look, that means in algebra, you know, you can add, subtract, multiply, divide same term. Same term. Same term means if both having same term, x, same variable, we can multiply, add, subtract, or divide. Same concept here you apply. Same concept.
Okay.
Here you look. Here root 2, here root 2.
Yes, sir.
Take this root 2 near to this root 2.
Then 5.
Okay. Then look. 2x plus x. Your answer will be how much?
3 root 2.
2x plus x. Your answer will be how much?
2x plus x. 3x.
Same thing. 2 root 2 plus 2 root 2. Your answer will be how much?
3 root 2.
Plus. Same 2x minus x. Your answer will be how much?
2x minus x.
Hmm.
1x. Sorry, x.
X. Same thing. 5 root 3 minus 3 root 3.
2x. 2 root 3.
2 root 3. Okay, you understand how to? And here
Yes.
we never add because different term, different variable. Like different variable. Okay, like can you add 2x plus 3z? No, na, because variable are different. Here also look root 2 root 2. So we can never be simplify it. Okay,
Okay, sir.
same thing for multiplication. Look, 6 root 5 multiply by 2 root 5. Okay, tell me how you multiply in algebra. 2x into 3x. Your answer will be how much?
6x.
First multiply the coefficient 2 into 3. Multiply also variable, means x into x.
Square.
6x square. 6x
Yeah.
square. Same thing here, you look. 6 into 2, root 5 into root 5. Root 5 into
Okay.
6 into 2,
22, 8.
6
Sorry,
into
12. 12.
12. Root 5 into root 5,
Into root 5, 5, sir.
5. You understand how to multiply?
Yes, sir.
Divide. Look. 8 root 15 divided by 2 root 3. Okay? If you look initially, you will tell, sir, it will be never happen. But look. Can I write 15 as root 3 into root 5
Yes, sir.
divided by 2 root 3? Root 3 cancel. Remaining is 8 root 5 divided by 2.
Yes, sir.
If I cut this also, 4 root 5. 4
Root 3.
root 5.
Root 5.
Okay? Okay. Are you understanding?
Yes, sir.
The examples may lead you to accept the following facts, which are true. The sum difference of a rational number and a irrational number is irrational. Look, the sum difference, which we have already complete. If you read this concept, you understand. Okay? Don't waste the time. Then come to, this is not in your part. Leave this. Come to, look this identities. Look this identities. You learn identities in uh, algebra, na?
Yes, sir.
Like here you look. Root AB, root AB. I can write this root AB as root A into root B.
Yes,
Okay,
sir.
I can write this as root A into
Root B.
root B. Suppose the example is root 14. Root 14. I can write this root 14 as a root 2 into root 7. Root 15,
Root 3 into root
I
5.
can write 3 into 5, and I can write separately root 3 into root 5. You understand the first identity?
Yes, sir.
Then same thing. Square root of a numerator and denominator. I can write separate. Square root of a numerator divided by square root of a denominator. Whole 3 upon 7. I can write it as root 3 upon root
7.
7. Okay?
Okay, sir.
Then the third property. Root A plus root B. Root A plus root B.
B.
Root A minus root B.
Root B.
Tell me A plus B, A minus B. It is an identity in your math, na?
Mm.
Then what will
A
be?
plus B.
Uh, it will be A square minus B square, na?
Yes, sir.
The same thing. Root A square minus root B square. A root square means A minus B. Okay. If you check, otherwise look. Root A plus root B whole into root A minus
Root B.
root B. What does it mean? Root A multiply with this term
Mm.
plus root B multiply with these two terms.
Mm.
Root A into root A. Your answer will be how much?
Root A square.
Root A square or A?
Yes, sir.
Root A minus root B minus
Root.
root AB. First property. First property. Okay. Plus root B root A. Answer will be how much?
Root B
Root AB
A.
minus
B
root
A.
Root b square means b. Okay, you can write root a square or root b square. Okay,
Okay,
plus
sir.
ab minus ab cancel.
Mm.
Root a square means a minus b. Okay,
Okay, sir.
it's like this. Look, 5 plus root 3. Sorry,
5 root 3.
root 5 plus root 3. Root 5 minus root 3. Your answer will be how much?
Root 5 minus root 3.
5 minus 3. Direct apply 2. Okay, this is
Okay, sir.
this identity how you help during calculation. Then the next will be fourth number. A plus root b. A plus
Root B.
a minus
Root B.
root b. Look, you have to multiply a into
A
a
square.
square minus a into root b. Your answer will be
AB. Root
hmm,
AB.
how you root a b? It is inside root.
A root B.
A root b plus b into a. Root b into a. Your answer will be
A root B.
and root b into root b minus root b
0. Sorry.
multiply minus
Multiply.
root b square
Root B.
minus a root b plus a root b cancel. Your answer is a square minus b because root b square is b na.
Mm.
I am giving you example you can understand. 5 plus root 3. 5
Mm.
plus root 3. 5 minus root 3. Your answer will be how much? A square means here a equal to 5. Here a equal to
5.
5. B equal to root 3 means 5 square minus b.
B.
B only b. It will be 25 minus 3. Your answer will be 22. You understand the identity?
Yes, sir.
Remember this identity. Whenever we require, we will apply during the calculation.
Okay, sir.
Then identity number B. Root A plus root B into root C plus
Root.
root D. Okay. This root A multiply with every term of this root C plus root D plus root B root C plus root D. Okay. Root A root C. Your answer will be how much? Root A root C. Tell me.
Sir,
Root,
answer?
root A into root C. Your answer will be how much? Root AC?
Yes, sir.
Root A root C. I can write it as root AC
Mm.
plus root AD plus root BC plus root BD. You understand this identity?
Yes, sir.
The example is like this. Root 5 plus root 3. Root 5 plus
Root 3.
root 3. Root 2 plus root 5. Root 7. How much your answer? 5 into 2. A into C. Root 10
Root.
plus A into D. A into D. Root 35. Okay. Then BC. B into C. Root 6 plus BD. Root 21. Okay.
Okay, sir.
This is your answer. The last one. Root A plus root B whole square. You know A plus B whole square?
Yes, sir.
What will it will be?
The
A
2AB.
square plus 2AB plus
Square.
B square. Here root A square how much? A root B 2 into root AB plus B. This is the formula. Look.
Okay.
Ah, you understand?
Yes, sir.
Look, some question. Here we have to apply the property. By looking this, tell me, it is comes under which property?
A square plus b square.
Square plus b square.
No, no. X plus a, x minus b.
Are look the first question, na? Look, this is your identity. This is your question. Which one is suitable for this?
A, b.
This is not. This is not. In first term, look. In all the identity,
Mm.
such anyone in which all the term are different, na? Look.
Mm.
That means it is A, it is B, it is C, it is D. This is the term.
Okay, sir.
Then answer will be A into C.
Root,
A into C. 5 into 2 how much?
root 5 into c.
5
5.
into
5 to 10.
10 plus AD. A into D. 5 into root 5.
5
And,
into
hmm,
uh, into root 5. 5 root 5.
5 root 5 plus 7 in, B into C. 7 into 2.
2 root 7.
Root 2 root 7, yes. Plus root 7 root 5.
Sir, root 7.
Root 5.
Root 7 root 5. 7 plus
Root 7
root
into root 35. Okay.
Okay, sir.
Easy to simplify? No. Any term are not like, so here this is the answer. Look your book. Look, the answer is this, no? Look. 10, 5 root 5, 2 root 7, root 35. Are you looking? First question answer.
Yes, sir.
Then look the second question. 5 plus root 5, 5 minus root 5. First you identify which
5 minus root 5.
which one?
Answer square minus root square. Sorry. 5 square minus 5 root square.
Hmm? 5 square minus 5. This identify. Look.
Yes, sir. I got it.
Just wait 1 second. Hmm.
Mm.
Look. A plus B, A minus B. Are you can apply this also. But here in first term root over is not there, na? So that's why I am applying this. 5 square minus 5. 5 square is how much? 25 minus 5. 20.
20.
Look the answer. 20. Root 3 plus root 7 square. It will be which? Which one?
Root 3 plus root 7 square. A square plus b square.
Okay, that means root A means 3 plus. You can say, sir, A is root 3 or look the formula. Here is root A, na? If you square the root A, your answer will be A, na?
Yes, sir.
3 plus 2AB. 2 into AB will be how much?
2ab 3 7th 21. Root 21.
Plus B. 7. 7 3 ja? 7 plus 3? 10 plus 2 root 7. 10 plus 2 21. 2
21.
square of 2 21 root over. Look. Last one you told me. Which property I will use?
Which one, sir?
I think this week in the next class I will complete this chapter. Hmm.
Square root of 11
Hmm.
minus 7.
11 minus 7.
Hmm.
Your answer will be 4. This property here I am using. Okay.
Okay.
This is the identities which I am applying.
Okay.
Then the concept is rationalize. Rationalize. New concept is
Rationalize.
means 100% the denominator is a irrational. Like this. Rationalize 1 upon root. Think. Rational divided by irrational. Rational divided by irrational. Your answer will be what?
Rational. Irrational, sir.
Irrational. Then here you have to do the rationalize. What does the meaning of rationalize? We want to write 1 upon root 2 as the equivalent expression in which the denominator is a rational number. Means converting the denominator from irrational to irrational, from
Rational to irrational.
irrational to rational, irrational to
Rational.
rational is called rationalize. It's called rationalization or rationalize. Okay.
Okay.
Then look, 1 upon root 2. Tell me how you convert? By multiplying
Both with the same number.
uh, same number.
2 root 2.
Root 2 divided by 2.
2.
Root 2 divided by
2.
2. Here the rationalized factor. The question is coming like this. Rationalized factor. Rationalized factor means here you are multiplying with root 2, na? You are
Yes.
multiplying root 2, na? This is called rationalized factor. This is called rationalized factor.
Factor.
Look here. You understand?
Yes, sir.
Okay. Tomorrow I'll discuss. Here is some interesting things is coming. Okay.
Okay.
It is not like that 1 upon 2 plus root 3. According to the above rule, you can multiply 2 plus root 3. Okay. But here you will get wrong result. Okay. How to do this? I will discuss in the next class. So your homework is exercise 1.4. You can able to do question number 1. Identify rational or irrational.
Okay, sir.
Okay. Then simplify each of the following. You can able to simplify by using the identities.
Okay, sir.
Then these two questions. Question number 1, question number 2.
Okay, sir.
Okay. That's enough for today class.